So let us take another example and try to understand the words image, domain, codomain, and range of the relation. Now let us take the relation whose name is S. I represent the relation as S. Is a resident of, that is, lives in. And this relation is being defined on two sets A and B. That is, this relation S is being defined from the set A to set B. This is how I write. S is a relation defined from set A to set B. And what are the elements of set A? For example, set A contains Narendra Modi, Donald Trump, and Xi Jinping. And set B contains 4 countries: India, America, China, and Japan. So let us take that this relation S is defined from A to B. And the definition of the relation is a resident of. Now, this S relates which element to which element? That's what we need to understand. So what are the elements that this S connects? So now, does this S connect Narendra Modi to India? So the question that we need to ask is Narendra Modi a resident of India? Yes. Narendra Modi lives in India. So Modi is connected to India. So is Modi a resident of America? No. So these two will not be connected by this relation. NM, will it be connected to China? No, because he is not a resident of China. He is not a resident of Japan. Next, go to Donald Trump. Donald Trump, is he a resident of India? No. So Donald Trump, is he a resident of America? Yes. So I connect these two. And Donald Trump, is he a resident of China? No. So these two will not be connected. This will not be connected. And Xi, is he a resident of India? No. He is not a resident of America. He is the president of China. So he should be a resident of China. And he is not a resident of Japan. So this S relates NM to I and DT to A, XJ to C. So these are the 3 connections that we make. So how do we write this? So the different ways of writing is S is a relation. S is equal to the relation which contains ordered pairs NM, I, DT, A, XJ, C. That is, this relation S contains 3 elements. These 3 ordered pairs. Next, I can also write something like this. NM is S related to I. So Narendra Modi is being related to I by the relation S. DT is S related to A. XJ is S related to C. So this is another way in which I can represent. Next, so this element which is in the second set is called the image of the first set. So if Narendra Modi is being related to I say that I is the image of NM from this relation S. So S of NM is nothing but I. That is, NM is connected by S to I. Or I is the image of Narendra Modi with respect to the relation S. What is the image of Donald Trump with respect to this relation A? What is the image of XJ with respect to the relation S? Is equal to C. So the second elements which are connected to the first elements are called images of the first elements. So in a relation, an element can have more than one image also. If you have a different definition of relation, you can have more than one arrows also. So now you have understood the concept of image. Image is nothing but the second element to which first element is related. Next, let us look at the terms domain, codomain, and range. So if a relation is defined from A to B, the set of elements in A which are related to the elements in B is called the domain of the relation. That is, once you write the relation in roster form, the set of all first elements is called the domain. So domain is the set of all first elements of different ordered pairs, that is NM, DT, XJ. So this is called the domain of the relation A. So sometimes it might happen that there might be some elements which are left out here. So for example, if I take Nawaz Sharif also here. So we know that Nawaz Sharif lives in Pakistan. So Nawaz Sharif will not be related to India, will not be related to America, will not be related to China, will not be related to Japan. So this guy does not have any connections. So this guy does not come in the domain. So domain is the set of all elements which are connected to at least one element in the second set. And codomain. Codomain is nothing but the complete set B. The complete second set is called the codomain of the relation. And you have the third term, range. Range is nothing but the elements of the second set which are related to the first set. That is the set containing I, A and C. So in the codomain you have I, A, C as well as J. In the range you have only these three elements. So the elements to which the first set elements are connected are called the range of the relation. And the domain of the relation is the set of elements in A with which connections are made. And codomain is the total second set. So I hope you have understood these four terms. Image means the second element corresponds to a first element. Domain is the set of all first elements which are connected to the second set. Range is the set of all second elements which are connected to the first elements. Codomain is the total second set. So these are the different terms that you need to understand. Now let's go forward. So now let us take this example. So let us say that a relation R is defined from set A to set B, where set A is the set 1, 2, 3, 4, set B is also 1, 2, 3, 4. A relation R is defined from set A to set B and is defined as is greater than. So if a certain element of the first set is greater than the element in the second set, then they will be connected. So now, let us see what connections can be made using this relation. So is 1 connected to 1? So the question that you need to ask is 1 greater than 1? No. So 1 is not greater than 1, hence 1 and 1 are not related. Is 1 greater than 2? No. Is 1 greater than 3? No. Is 1 greater than 4? No. So 1 is not connected to any of these elements. So now let us go to 2. So is 2 connected to 1? The question that you need to ask is 2 greater than 1? Yes. Hence 2 and 1 will be connected. So is 2 greater than 2? No. Is 2 greater than 3? No. Is 2 greater than 4? No. So there won't be any of these connections. So is 3 greater than 1? Yes. 3 and 1 will be connected. Is 3 greater than 2? Yes. 3 and 2 will be connected. So 3 will not be connected to 3. 3 will not be connected to 4. So is 4 connected to 1? Yes. 4 is connected to 1. 4 is connected to 2. 4 is connected to 3. And 4 is not connected to 4. So in the first set, 1 is not connected to any of these elements. In the second set, 4 is not connected to any of these elements. So now, how can I write R? This is the diagrammatic form of this relation. So R can be represented in a roster form as the set containing ordered pairs 2, 1, right? 2, 1 and 3, 1, 3, 2, 3, 1, 3, 2 and 4, 1, 4, 2, 4, 3. So these are the 6 elements that are present in the set R. So R can be written in roster form like this. And R can be written in diagrammatic form like this. Right? The set builder form of R, R is nothing but R is a set containing ordered pairs x, y such that x comma y both belong to the set 1, 2, 3, 4 and x is greater than y. So this is the set builder form for R. It is R contains the ordered pairs x comma y such that both these elements come from these sets and my x coordinate has to be greater than y coordinate. Next, R can be represented in graphical form also. So if I want to represent R in graphical form, as we have seen, so the first coordinates, the numbers in the first coordinate has to be represented on x-axis. So 1, 2, 3 and 4. And the numbers in the second set are represented on y-axis 1, 2, 3, 4. And each connection corresponds to an ordered pair and each ordered pair corresponds to a point on the coordinate system. So first point is 2, 1. So 2, 1 is this point. Next 3, 1, 3, 2, 3, 1, 3, 2 are these 2 points. 4, 1, 4, 2, 4, 3. So these are the 6 points that are present in R. Right? So in the question, if he wants to talk about this set, the first way that he can talk about this set is R is defined from set A to set B defined by is greater than. This is one way. So what are the other ways in which I can write the same information? So I can write something like this. The elements in the first set are usually represented by x's and the elements in the second set are usually represented by y's. The first coordinate of the point are represented by x, the second coordinate is represented by y. So now what I write is x is R related to y, an element x in set A is R related to y if and only if x is greater than y. So if some expression like this is given, this also means this. That is, this relation R connects x to y if and only if x is greater than y. So this can also be written. Both these are same. And this can be written. R contains elements x comma y such that x is greater than y. So this is also one way to give the same information. So in exams, you can expect the relation to be given in any of these forms. You should be able to understand. Now once you have this relation, if you are asked to find the domain, codomain and range of this function. So what is the domain of this function? Domain of this function is nothing but the set of all first elements when this set is written in roster form. So as you can see, the first elements are 2, 3 and 4. So the domain is the set containing 2, 3, 4. Right? And what is the range of this set? The range is nothing but the set of the second elements of all the ordered pairs. It is the elements in the second set which are connected to the first set. So the range of this set of this relation will be 1, 2, 3. And what is the codomain of this set of this relation? Codomain is nothing but the whole second set, that is 1, 2, 3 and. So I hope you have understood what domain, range and codomain of the relation is. Now what is the image of 2 with respect to this relation? R of 2 is nothing but 1. R of 2 is 1. Next, what is the image of 3? The image of 3 is both 1 and 2. So the image of 3 is 1 or 2. So you can write it in the set containing 1 or 2. So you can write this in set. So R of 2 is set 1. R of 3, the image of 3 is the set 1, 2. The image of 4 is the set 1, 2 and 3. Right? So in this question, what we have seen is a mathematical definition. Till now we have seen general definitions of relation. So here you have a mathematical relation x greater than y, and by this relation you have certain arrows, and correspond to each arrow you get an ordered pair. you can represent a relation in roster form, set builder form, diagrammatic form, or graphical form. And these are different ways in which you can write the same relation. And once you write the relation, you can find the domain, codomain, and range, and image of any point. So now let us again go forward.